Right, notes 8.2 are on linear versus nonlinear functions. And the most important thing you need to understand is that linear comes from the word line. So if something is a linear function, it makes a line. So, and we've done a lot of stuff with linear functions this year, so you should be okay with that material.
It says, how do you find out if a function is linear or nonlinear to begin with? So we need to actually understand whether it's linear or not. And the way we can tell if something is linear is if, let's write this out, it has a constant rate of change. Now, don't forget that another word for rate of change is the slope. So we can also say that it has a constant slope. All right. So if you were to look at a graph of something that is linear, it would end up looking like this or like this. It's basically a line. Linear means line. It's a straight line. And because of that, it has the same slope no matter where you look at on this line. The slope is always the same, so it's constant. It never changes. Okay, so let's look at question number 1. Identify if the following functions are linear or nonlinear. Now remember, we learned a long time ago that the formula for slope is y2 minus y1 over x2 minus x1. But here's the thing that you guys can do right here. I can just choose any random set of points. So I could choose like 118, 212, find the slope of those 2 points, then choose any other 2 random points and find their slope and compare them. And if they're the same, then it's constant. It has the same rate of change. But here's the thing, y2 minus y1 just basically means you're subtracting, you're finding the difference between these two numbers. And x2 minus x1, you're just finding the difference between these two numbers here as well. So what I'm going to do is I'm going to look at what values I have here. So from 18 to 12, it's decreasing by 6. From 12 to 0, it's decreasing by, let's use a different color, it's decreasing by 12. All right. From 0 to negative 18, this is decreasing by negative 18. And then from negative 18 to negative 24, this is decreasing by 6. Okay, and I'm going to do the same thing for my x values. So these x values are increasing by 1. These x values right here are increasing by 2. These x values right here are increasing by 3. And these x values right here are increasing by 1 from 7 to 8. Okay, so again, the way I'm figuring it out is 1 to 2, I'm adding 1, 2 to 4, I'm adding 2, 18 to 12, I'm subtracting 6, 12 to 0, I'm subtracting 12. Now, the rate of change is the change in y over change in x. Okay, we also talked about this formula as well. This is the delta symbol. It means the change. So the change in y over the change in x. So from the first to the second coordinate, the change in y is negative 6 over the change in x, which is 1. So I know that this rate of change is negative 6. Okay, I'm going to do the same thing with the next set of coordinates. So from 212 to 40, the change in y is negative 12. The change in x is 2, which is negative 6. The next one is the change in y is negative 18 over the change in x, which is 3. So if you look right here, sorry, this should be a negative 18 right here. Okay, so if you look at this right here, we've got negative 18, and then it's over 3. So I end up getting negative 6 again. And then let's do the same thing with the last set of coordinates. We ended up getting negative 6 over positive 1, which is negative 6. So if you notice, every single one of these coordinates from one coordinate to the next has the exact same rate of change. They're all negative 6, so it's constant. It doesn't change at all, which means that this relationship is a linear relationship. Okay, so we're going to say this is linear because it has a constant rate of change. So linear because the rate of change is constant. Hopefully that makes sense to you. We'll do another one just to make sure you're okay with this stuff. Okay, so again, the rate of change is constant. All right, so let's do the same thing. We're going to find out what the rate of change is. So remember, the slope is the change in y over the change in x. So I'm going to figure out how much the y is changing by. So from 28 to 26, this is changing by 2, but it's going down by 2, so it's a negative 2. And then from negative 5 to negative 3, this is changing by positive 2. It's increasing by 2. So the rate of change is negative 2 over positive 2, which is negative 1. Okay? All right, let's do it for the next set of coordinates. So 26 to 24, this is decreasing by 4, and this is increasing by 2. So our rate of change would be negative 4, that's the change in y over the change in x, which is negative 2, which you should notice something right now, but we'll just do a couple more just to be okay with this stuff. Next one, 22 to 14, this rate of change, this is going down right here by 8. So this right here, we're going to say negative 8, and this is going up by 2, so I'm going to have negative 8 over 2, which is negative 4. Now, if you notice, when I do every single one of these problems, my rate of change is not constant. It's not staying the same, which means that this is non-linear, okay? So what we're going to say is this function is nonlinear because the rate of change is not constant. Okay, and hopefully that will make sense to you. Okay, so now for questions 3 through 4, it says determine if the graph is a function, then determine if it is linear or nonlinear, and then if it is linear, just find the rate of change. So there's 3 parts to every single one of these questions. The first part is A, determine is this a function or not. B, determine if it's linear or nonlinear, and then C, determine the rate of change. Okay, so first of all, we need to look at 3, and I'm going to try the vertical line test, remember the VLT. So if I were to draw any vertical line through my points right here, it should only pass through my function once. So every vertical line that I draw through right here only intersects my function once, so it really truly is a function. So the answer to part A is yes, it is a function. Because it passes the vertical line test. Okay, now part B asks us to figure out, is this linear or is this nonlinear? Now I can figure out if it's linear or nonlinear when it's a graph just by looking at it, because remember, linear means it's a line. So in number 3, it is a straight line, which means that it is linear. Okay, so part B, the answer to that question is that it is linear. Okay, and then lastly, I need to find the rate of change if it is linear. Because it is linear, I can find the rate of change. Now remember, there's several different ways I can do this. I can figure out how much the change in y is over the change in x. So I can figure out that it went down 3 and over to the right 1. So I can say it's just negative 3. Okay, but remember, we can just go ahead and use the slope formula, which is, this is a good review, y2 minus y1 over x2 minus x1. And if you look back at your coordinates were 0, 3, and 1, 0. So I'll go ahead and write that out, 0, 3, and 1, 0. So when I plug it into my formula, the y2 is 0, the y1 is 3. Okay, I'm not going over this because this is all review. x2 is 1, x1 is 0. So I end up getting negative 3 over 1, which is negative 3. Okay, so the rate of change is negative 3. All right, so let's look at question 4. Number 4, determine if it's a function or not a function. You try it yourself, see what you get, and then compare with me. Okay, so if I were to draw vertical lines through my function right here, Each vertical line will only intersect once, which means that it is a function. So it's the same thing. A, yes, it is a function because it passes the vertical line test. All right, and then the next thing I'm going to do is just see if this is linear or nonlinear. Of course, it is not linear because it is not a straight line, so we're going to say B nonlinear. Because it's nonlinear, I cannot find the rate of change because the rate of change is constantly changing. So it is nonlinear, and I am done with that question. All right, see you soon.
And we will be doing question number 5 together as a class.